Hello, and welcome to Tennessee's at-home learning series for math. Today's lesson is for our 8th graders out there, though all students are welcome to tune in. This lesson is the 14th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson today. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education website that I actually have pulled up here. If you will scroll down and find the math grade 8, the independent practice that you can complete at the conclusion of today's lesson can be found in the student packet. Today we'll be learning about systems of linear equations, and we'll be working to estimate solutions by using inspection and elimination. Before we get started, to participate fully in our lesson today, you will need the following: paper and pencil and a hard surface to write on. A calculator is not required, but may be used to check calculations. Are you ready to get started? Okay, let's begin. So you may recall we have used this chart in our previous lessons. This chart is used to tell me the maximum heart rate based on a person's age. Remember that X represents the age of a person and Y represents the maximum heart rate. So here's what we wrote in our previous lessons. In this equation, X represents the age of a person and Y represents the maximum heart rate. Let's work together to find a problem related to this same chart. Cassandra and Jasmine like to run together. They both try to maintain a heart rate that is 60% of their maximum heart rates, meaning they are trying to keep their heart rate at a certain number while they are running. Jasmine is 5 years older than Cassandra, so she thinks her 60% of her maximum heart rate must be 5 beats per minute lower than Cassandra's. Do you agree? To answer that, let's first decide what expressions we'll use for Cassandra and Jasmine's ages. We can use X to represent Cassandra's age and X plus 5 to represent Jasmine's age because she is 5 years older. So we have that written here. What expressions show 60% of the maximum heart rate for each person? For Cassandra, we can use this expression here. And then for Jasmine, we can use this expression here. We don't know their exact ages, but remember, we're trying to figure out whether or not 60% of Jasmine's maximum heart rate is 5 beats per minute lower than Cassandra's. So the actual age of the two people doesn't matter, just the difference between the heart rates, their ages. You can pick any two ages that are 5 years apart and it will solve the problem. So using the following expressions, we get this. So I simplified this expression here and I simplified this expression here. Then we want to solve for Jasmine's heart rate. So I take Cassandra's heart rate and I subtract Jasmine's heart rate. And if you notice, I get 3. So guys, what that means is that Jasmine's heart rate is 3 beats per minute lower than Cassandra's, not 5. So we would have to disagree with Jasmine's original assessment. That was a good warm-up. Let's look at some other problems. Are you ready? Okay, let's get started. Eliminate means to get rid of something. Simple enough, right? But in mathematics, the elimination method is a great way to solve a system of linear equations. Elimination can be used to solve a system of linear equations by adding or subtracting the equations to eliminate one variable and using the result equation to find the other variable, or identify if there's no solution or an infinite number of solutions. As we work through the problems, keep in mind that a system of equations must have one pair of terms with coefficients that are the same or opposites for a term to be eliminated by adding or subtracting. Let's use elimination to solve some problems. Remember from the previous lessons, listen to the information first, then grab your pencil and paper to follow along. First up, we're going to try to solve this riddle. So our riddle says that 2 times a number 2 times a number x plus a number y equals 8. Four times the number x minus the number y equals 4. So here's our riddle if you want to write that down as well. So how can we use this system of equations to solve the riddle? Okay, so we have 2 times the number x, so 2x, plus a number y, so plus y, equals 8. Then we have 4 times the number x, so 4x, minus the number y, minus y, equals 4. Okay, try to write along as we eliminate one of the variables. So we see that these are opposites, meaning I can add, and I get 6x equals 12, or x equals 2. As you can see, we eliminated the y variable here. This helps solve the system because the result is an equation with only one variable x, which can be solved to find the value. Then the value x can be substituted into one of the equations to find the value of y. This will give us a single solution to the problem. You can also see that the sum of the coefficients y terms is 0. The addition property of equality allows us to add equal values to both sides of the equation to eliminate y. So now that we have x, let's solve for y. Follow along with me. Remember to substitute the value of x into either one of the equations like this. I'm going to choose this first equation, and I'm going to put in 2 instead of x. I'm going to plug in 2 plus y equals 8. So 4 plus y equals 8, y equals 4. Okay, let's look at another problem. Write down this system of equations. So I have 2r plus 3s equals 14 and 6r minus 3s equals 6. How should we go about solving this? Well, we can use the addition property to eliminate s and solve for r. As I write this down, try to follow along with the same result. So I'm going to add these two together. I'm going to get 8r plus 0 equals 20. So r equals 2.5. Did you get the same answer? So now that we have r, we can solve for s. See if you can follow along. So I'm going to use this first equation here and plug in the value of r. So I have 2 times 2.5 plus 3s equals 14, which gives me 5 plus 3s equals 14. 3s equals 9, and so s equals 3. Look at this one a little closer. Are there opposite terms in this system of equations? Yes, the opposite terms are positive 3s and negative 3s. What would be a way to check your solution? You could substitute r equals 2.5 and s equals 3 into the second equation to make sure it can be solved correctly. Now that we've done a few problems using elimination, can you tell me when you add equations in a system? That's right. When they contain a pair of opposite terms, just as these did here. When would you use subtraction? You got it, when the system contains a pair of equivalent terms. Let's work a few more problems, and this time we'll focus on solving by subtracting. Listen to the following problem, then get that pencil and paper ready. Be thinking about what information you'll need to write your system of equations as I read the problem. So here is the first one. Hannah is helping her younger brother learn to count money. She gave her brother a total of 20 coins, all nickels and pennies. Hannah's brother said he counted 68 cents. How can Hannah solve a system of equations to tell whether he counted the money correctly? First, let's write our system of equations to relate the number of nickels and pennies. We're going to let x equal the number of pennies. Scoop that up. We're going to let x equal the number of pennies and y equal the number of nickels. We know that the total number of coins is 20 and the total value of the coins is 68 cents. So our system should look something like this. I know when I add my pennies and nickels together that I had 20 total coins. I know that the value of pennies is 1, so there's just an understood 1 to be my coefficient here. I know the value of nickels is 5, and I know that when I add these two values together, I have 68 cents. So now that I see I have the same coefficient here, I can use the substitution property. So when I subtract that, I have 0 minus 4y equals negative 48. And then I have y equals 12. So now what I'm going to do is I'm going to plug in this value and solve for x. So if Hannah gave her brother 8 pennies and 12 nickels, then he definitely counted correctly. Would the solution be different if you subtracted the first equation from the second equation? So notice I went this equation minus this equation. No, it would be the same because changing the position of the equations when you use elimination does not change the solution. Let's look at a few more and you work along with me. I'm going to walk you through one, but if you want to get your pencil and clean paper, you can follow along. We're going to use elimination to solve the following system of equations. So I have 3x plus 2y equals 17, and 6x minus 2y equals 28. I'll give you a moment to write that down. Okay, so if you notice, we can eliminate my y variable since both of these coefficients are opposites. Would we use addition or subtraction to eliminate that y variable? Right, we would use addition. So when I add these together, I'm going to get the following. I have 9x. I'm going to add positive 2y and negative 2y, and I get 0, and that equals 45. And so I get that x equals 5. So now that we have our value of x, we can then substitute and solve for y. it should look something like this. I'm going to use that first equation here. So I have 3 times 5 plus 2y equals 17. 15 plus 2y equals 17. 2y equals 2, and y equals 1. So now we found our values. X equals 5 and y equals 1. Or we could write it as an ordered pair like this, 5, 1. Okay, here's one more for you to try on your own. Let's see if we can find this problem. And I've highlighted some key information for you here in this problem. So it says we have 2 balloons, balloon A and balloon B. They have a total volume of 3/5 of a gallon. Balloon A has a greater volume than balloon B, and the difference of their volumes is 1/5 of a gallon. Can you fill in the blanks to create your system of equations? So write this on your paper. So A plus B equals blank. A minus B equals blank. And so we're going to let A represent the volume of balloon A and B represent the volume of balloon B. Here we go. So take a moment, see if you can fill in the blanks. Okay, did you get something like this? So we know that together the volumes have a total volume of 3/5, so A plus B equals 3/5. And then we know that the difference of their volumes, so A minus B, is 1/5. So this is what your system should look like. So we want to use elimination to solve this system of equations. Can you add the equations to eliminate B and find the value of A? See if you can do this one on your own. So I'm going to add these to eliminate B. So I have 2A equals 4/5. When I divide by 2, I have that A equals 2/5. So now we can substitute 2/5 in for A. How can you find the value of B? Good. So we're going to plug in this value for A. And so I have 2/5 plus B equals 3/5. So that's going to give me B equals 1/5. Great job. Here's another one for you to try mostly on your own. So have your pencil and paper ready and listen carefully. All right. So a basketball team made 56 successful shots. There were a combination of 1 and 2 point shots. The team scored 94 points in all. Can you use elimination to solve this system of equations and find the number of each shot? So how would we begin to solve this? Let's say that X is our 1 point shots and Y is our 2 point shots. How can you use this information to create your system of equations? So we know that together, the 1 point and 2 point shots together gave us a total of 56 shots. So my first equation can be X plus Y equals 56. We know that the value of X, that's representing my 1 point shot. So that's 1, my coefficient, understood coefficient of 1 there. plus my 2-point shots, 2y, is going to equal 94 points total. So you should have set up something like this. Now use elimination to determine how many 2-point shots were made. Okay, let's take a quick look at your progress. Did you begin with x plus y equals 56? And notice that I have the same coefficient. So since they are the same, I'm going to subtract these two equations from one another. And when I do that, I get negative y equals negative 38. And so when I divide by that negative 1, I get that y equals 38. So from this, you now know that there were 38 2-point shots. You can determine the number of 1-point shots using this information. You can use either equation to plug this information back into, but let's try the simplest equation. So I'm going to use the top equation here. And where I see y, I'm going to plug in 38. So I have x plus 38 equals 56. And I know that x equals 18. You are really getting the hang of this. Let's try one more example before we call it a day. So here is your system. First, I want you to choose which variable to eliminate. Looking at the system, which variable would you choose? I think we can use the addition property of equality to add the equal values of both sides of the equation to eliminate x. So let's add those together and see what you come up with. Okay, so you should have come up with 9y equals negative 9, or y equals negative 1. So now that we have our value of y, we can substitute that in and solve for x. Remember, you can use either equation to sub that back into. Give that a try. So here's what I found when I used the first equation. I had negative 6x plus 5 times negative 1 equals 1. So negative 6x minus 5 equals 1. Negative 6x equals 6, and x equals negative 1. So now we found our values. X is negative 1 and y is negative 1. Or we could write it as an ordered pair, negative 1, negative 1. Okay, here's one more example for you to try on your own. And then you can write this along with me. So I have 7x plus 2y equals 24. And 8x plus 2y equals 30. Which variable do you want to eliminate? Did you say that we could eliminate y? Okay, that's right, but will we add or subtract in this case? Right, we need to subtract because the coefficients of y are the same but not opposites. Let's model it this way. You write along with me. So I'm going to subtract this equation. and I'm going to get negative 1x equals negative 6, or x equals 6. So now that we have our values of x, let's substitute that back into one of the equations and find y. You try that and check it against my work. Okay, so I'm going to use this equation here. I'm going to plug in the value of x. So I have 8 times 6 plus 2y equals 30, which gives me 48 plus 2y equals 30. 2y equals negative 18, and y equals negative 9. We have found the solution. X equals 6, and y equals negative 9. Or we could write it as an ordered pair, 6, negative 9. How are you feeling about your skill level now? All right, guys, great work today. Today we explored solving systems of linear equations using the elimination method with addition and subtraction. After this lesson, you'll have a few problems to practice on your own. I will show you the independent practice problems now, which I've shown you at the beginning. Just scroll all the way down to Math Grade 8 and click on the student packet to access those. Good luck and do your best. I really enjoyed systems of equations using elimination method with addition and subtraction today with you. Thank you so much for inviting me into your home. I look forward to seeing you in our next Tennessee's at Home Learning series. Goodbye.